Hi there, welcome back to this channel. In this video, we are going to be considering the inverse of a matrix and essentially the inverse of a 2 by 2 matrix. In further video, we are going to see how to find the inverse of 3 by 3 matrix and the rest of that. All right, but there is a specific formula that you can use or that you can adopt to finding the inverse of a 2 by 2 matrix, and we are going to be considering all of those in this video. But before I continue, do want to subscribe to the channel and click the bell notification. Flag for those of you that are preparing for the upcoming jump. I promise you that you are going to get all the as much content as you need to pass your exams well, to have 300 and above here. So do want to subscribe to the channel. All right. So I said that we are going to be looking at the inverse of 2 by 2 matrix now. How do you calculate the inverse of a 2 by 2 matrix? So if I was given a matrix A to contain the following elements, so it contains 2, minus 3, 5, and minus 4. All right, so we are told to find the inverse of this matrix. First, how do we write inverse notation? Now, inverse notation is written like this: A for this element A, this matrix A raised to the power minus 1. If you remember well, even in indices, I think we did that if I had 1 over A, it will be written as A raised to the power minus 1. Right, so the notation doesn't change. It's the same way we write it. So we have A raised to the power minus 1. All right, so and this A raised to the power minus 1 is the same as 1 over A. Is that okay? It's the same as 1 over A. So this shows us that if we cross multiply, it shows us that A is this set A times or multiplied by its inverse should give us 1, which is an identity matrix. So a matrix multiplied by its inverse will give an identity matrix. And what is an identity matrix? So for a 2 by 2 matrix, our identity matrix is going to be a matrix that has its row, its main diagonal. I have 1 in its main diagonal and the other diagonal 0 0. Right, so this is an identity matrix. So what this is saying is that if we get so to prove that we are correct, by the time we multiply this matrix A by the inverse we should get an identity matrix. All right, let's do that. So the first thing you should know is that the inverse of the matrix, of this matrix A, for example, is given by the formula 1 over. So let's say I gave something like matrix A was A, B, C, D. Now, the inverse of this matrix will be 1 over the determinant of A, or you can write it as 1 over determinant of A. If that was you want to write it. So times, now you're going to take the minor of this. And how do you do that? The trick is, I'm just going to use a trick directly. What you just do is interchange this. So when you interchange this, that is in the main diagonal, you interchange the main diagonal so that D comes here and A comes here. So you have D here and A comes here. Then you now add negatives here. Do you understand? So you have minus. Now you are not changing this. B remains here and C remains here. Only that you are going to add negatives and negatives there. So that if in the question you're given, if in the main matrix you have a minus here, it's going to be a plus there. So if this was minus B, it's going to be a plus there. All right, so using this idea, we know therefore that A inverse is going to be equal to 1 over the determinant of A into bracket 2. Now 2 and minus 4 we interchange positions. So we have minus 4 will come here and 2 will come here. And then we have negative for this place. So we have negative this will give us 3 and negative this will give us minus 5. And that's that. So this is what we want to solve basically. Now how do we find the determinant of A? You already know that. So determinant of 2 by 2, determinant of A is going to be this main diagonal times itself. We're going to times the main diagonal and subtract from the other diagonal. So I'll subtract the other diagonal from the main diagonal. So here we have 2 times minus 4, all minus 3 times 5. All right, so here we have minus 8, here we have minus 15, and that becomes minus 8 plus 15, and that becomes 15 minus 8, and that is what? 7. So our determinant is 7. All right, so then we further continue. It means that our formula has become 1 over 7 multiplied by minus 4, minus 5, and 3 and 2 here. So simply what we'll do is we'll multiply this minus 7. We'll use it to multiply all the elements here. So we have A inverse will now become minus 4 times this. That's basically 1 over 7 times minus 4, 1 over 7 times 3, 1 over 7 times minus 5, and 1 over 7 times 2. All right, so our A inverse therefore becomes minus 4 over 7, 3 over 7, minus 5 over 7, and 2 over 7. Right, and that is the inverse of that matrix. All right. Okay, like I earlier said, I said we'll prove that we are correct by multiplying this our inverse. We are going to multiply our inverse by our actual matrix. We should get an identity matrix. All right, let's try that. So that's our matrix there. Let's multiply by our inverse. So A times A inverse will be equal to, what's our A inverse is? A inverse is minus 4 over 7, 3 over 7, minus 5 over 7, and 2 over 7. All right, so let's multiply them. And remember how to do 2 by 2 matrix, 2 by 2 matrix multiplication, row by column. Is that okay? Row by column. All right, so what do we have? We're going to have minus 4. Let me express it so that, for those of you that don't understand how to do multiplication, you will understand. I'm going to express in 4. Minus 4 over 7 times 2. So we have minus 4 over 7 multiplied by 2 plus 3 over 7 by 5, 3 over 7 by 5. That is for the first element in that place. Then the second element. Welcome, ma'am. Yes, ma'am. Then we'll have the next part. We're going to take this multiplied by this, and that will become minus 4 over 7, by minus 3, then 3 over 7 plus 3 over 7 times minus 4. All right. Then the other part, we have minus 5 over 7 by 5, minus 5 over 7 multiplied by 5, and 2 over 7 multiplied, 2 over 7. No. I think there's a mistake there. I'm distracted. This minus 5 over 7 is going to multiply this, row to column. Do you get it? Row to column. All right, let's go again. Minus 5, so you have to be careful. Minus 5 over 7 multiplied by 2, then plus minus 5 over 7 multiplied, then then 2 over 7 multiplied by 5. All right. Then the next case, we're going to have minus 5 over 7 multiplying this guy also. So we have minus 5 over 7 multiplying minus 3 plus 2 over 7 to multiply minus 4. All right, so with that, we can just, okay, so with that here, upstairs here, we're going to have minus 8 over 7 plus 15 over 7. And here we have 12 over 7, that is minus is minus plus, and 4 times 3, 12. 12 over 7 plus minus 12 over 7. All right, and here 5 by 2, 10. 10, so that is minus 10 over 7 plus 10 over 7. And here we have minus times minus, that's plus, that's 15 over 7 plus minus 8 over 7. Now if you look at this very well, this will become minus, they have a common denominator, so we don't have much work to do. So what you have here is minus 8 plus 15, that's 7 over 7. Minus 7 over 7, no, 7 over 7. Here, minus 8, here, 12 minus 12, 0. 0 over 7, 0. This also 0, and this also 7 over 7. So by the time you take care of that, you're going to have the identity matrix, and that is our answer. So it proves that this is the correct inverse of the matrix. All right, so that is how to take the inverse of the matrix. In the next video, we are going to consider the inverse of a 3 by 3 matrix. Thank you.